Okay, so let me, let's warm up. It's been, you guys had the weekend. Let's warm up here. Let's do, let me do a couple of questions and maybe you guys can do a couple of questions. And then I'll move into kind of the last topic, which is allegation, which is a word I haven't heard in a long time, but pretty easy topic here. Oh, Abdullah, yes, I'll talk about that in 1 second. Okay, so example number 8. Let's do example number 9 and 8, and then I'll kind of talk about the assignment and everything like that. So example number 8, example 8 and 9. Number 8, how many liters of a 25% volume by volume solution must be mixed with a 40% volume by volume solution to obtain 12 liters of a 32% solution? Sounds really complicated, but it's actually not too challenging. I'm trying to find out how many liters of this solution must be mixed with, how many liters of a 25% solution must be mixed with a 40% solution to obtain 12 liters. So first things first, the mixture of this solution here, I'm missing 2 numbers. I'm missing 2 volumes. So I'm going to say that the liters of the first solution will be the volume of the first solution will be X. I don't know this number, but I also don't know the other number as well. But what I do know is that the total amount, the total volume must be 12. So that means, and we did this last day on Sunday, so you guys you might not remember this, but I'll show this to you. It's not as bad as it sounds. I'm going to then make the other solution, this volume, I'm going to make this equal to 12 minus X. That way together they will equal 12. And now I'm going to write something down that I'm going to erase really quickly. But the way that this works is you take your mixtures, so like the concentration times the quantity of mixture 1, you add this to mixture 2, and that's going to equal your total mixture. Now, I am going to have to erase this because I don't have a lot of room here. But basically what I'm going to do is take the concentration and quantity of the first solution, multiply them together. I'm going to add that to the concentration and quantity of the second solution, add them together, multiply them together, and it will equal my total solution, my total being 12 times 0.32. Another thing I should mention, guys, is we always write percentages as decimals. So unfortunately, I do have to erase this because they don't give me much room to write in here. But you'll see me write it down. Just watch what I'm about to do. So my first mixture, my 25% solution, that's going to be 0.25 times X. I'm going to add that to my second solution, which is 0.40 times X. Not X, but times 12 minus X. And that's going to equal my total solution of 0.32 times 12. And now I'm just going to solve for X. This was example number 8 is a little bit more difficult than example number 7 because I do actually have to multiply this out and solve for X. But this question now that I have it set up, is easy. It's kind of just straight algebra like you guys would have done in, say, chemistry or physics or math. 1700 or whatever math course you guys did before this, just straight algebra. So I get 0.25x plus 0.4 times 12. I hope I didn't do this one yesterday, by the way. Or sorry, not yesterday. I mean Thursday. So when I do this, I get 4.8 times, or sorry, minus 0.40x. Okay, just making sure I did my calculations okay. Yep. And then 0.32 times 12 on the other side is going to equal 3.84. Okay, so I'm going to do my x's. So 0.25 minus 0.4 gives me negative, which is kind of weird. You're thinking, uh-oh, I got a negative 0.15x. But when I move the 4.8 over, that's going to give me a negative as well. So finally, and I'm doing like all the steps here. You guys do not need to show me all these steps, but I'm just going nice and slow for our first question today. Is negative 0.96. So finally, x will be that divided by 0.15. So I end up getting 6.4. Now, I haven't answered the question. Well, I guess I did, didn't I? It says how many liters of a 25% solution must be mixed? 6.4 liters. I know it's liters because the units I'm using are liters. So that's it. The other solution, if you're curious, which let me change my color here. Hold on now. Tools, give me 1 second. I always forget to do this. I'm just going to change the color and write it in red. My other, so this is the answer. The other solution would be 12 minus 6.4, which would be 5.6 liters. But this is the answer because the question only says, how many liters of the first solution do I need? So 6.4. Not too bad. Okay. Let me set up number 9, and then maybe I'll get you guys to finish it for me. And then we'll talk about some stuff like Abdullah asked a question in there earlier, which I'll get to. Just let me set up number 9. I'll get you guys to solve it, and then we'll move on. Okay, this is an interesting one. How much pure zinc oxide should be mixed with a 10% zinc oxide solution to make 3.75 kilograms of a 12% zinc oxide ointment? Okay, so it doesn't really say here, but we're going to assume the percentages are by weight. I think that's kind of a typo in the question. Typically, next to the percentages, you would have, V over V or W over V. It's not really in this question, but I'm going to assume, and I'll have this very clear for you on an assignment or something, but I'm going to assume that this is 10% weight because we're dealing with weights here. Okay, the only challenge with this question is, well, there's 2 challenges. Is one, we set up the X's, but 2, what does pure zinc oxide mean? Well, pure, in theory, means 100%. That can be hard to get in real life. A lot of chemicals that we use in the lab are never exactly pure, but this question says it's pure. So I'm going to let the amount of this equal X, and the amount of the 10% I'm going to say is 3.75 minus X. My total amount subtract the amount of pure. Again, I hope that makes sense. If X is the pure zinc oxide, and in total I'm making 3.75 kilograms, well, then the other chemical must be 3.75 minus that, right? I hope that makes sense. So I'm going to take 100% X, which is 1X. Okay, so let me just write that down. 100% X is the same as just saying 1x, you divide it by 100, plus my other mixture, which is 10%, so 0.10 times 3.75 minus x is going to be my total amount. So 0.12 times 3.75. These questions actually, I teach Math 1700 as well. We do these in Math 1700 in a very much more confusing method. But I'm going to give you guys a minute. I want to see if you can solve this, and then we'll check your answers. And yeah, we'll have a chat about the test and assignment after that. So try to solve this for x. I'll give you, I don't know, 2 or 3 minutes, and we'll check your answers. Okay, let's look at the answer. All right, Reem, Samar, Kalsum, everybody's saying the same thing. That's perfect. So I don't know. Let's see. X plus 0.375 minus 0.10x equals 12 times 3.75, which I can't do in my head. That's 45. Okay, so this would be 0.90x. You don't need to put the 0 in there.
Sir, it's 0.45.
Yes, yes.
Oh,
Yes. Thank you. Sorry for that. When I did this on my calculator, that helps because I would have got a really weird answer. I forgot a decimal place when I did this on my calculator. Okay, so 0.90x equals 0.45 minus 0.375. And we'll get our answer. I'll just solve this. Okay, so x, when I solve this, it would be 0.45 minus 0.375 divided by 0.9. And let me check. I got decimal 0.083 repeated. Perfect. So 0.083 kilograms. Now, that might seem like a really low number, and it is, because like think about what this like. One thing I want to mention, your answer should make some sense. Like what I mean is, in this question, we're taking 100% pure zinc oxide, mixing it with 10% zinc oxide to make 12%. So I wouldn't need a lot of pure zinc oxide to do this. So, what I'm saying is if your answer for this was like 50 or, -6, like those answers don't make sense. It has to be less than 3.75. And again, I would expect this to be a little smaller because I'm mixing the 100% solution. Okay, so that's it for example 9. We'll do a couple more. There's a lot of examples here. 14, 15, there's at least 16, 7. There's so many examples. Oh my gosh, wow. I don't know why there's so many, but we'll do a couple more and then we'll get into this last part of chapter 3. Now, Abdullah asked a question earlier. Oh, Loa wants me to do question 10. I can do that. But Abdullah asked a question earlier. If your assignment is this week, can we move the test from Thursday to Sunday? And yeah, absolutely. You guys you're going to have a test, as I mentioned last week, on chapter 3, only chapter 3, not chapter 4. And I mentioned that it would be on Thursday, but if you guys would like the weekend to study for that, we can certainly have the test on a week from today. So it would be at 11:30 on Sunday. That works really well for me as well. So you guys, you have an assignment. You're going to have an assignment on chapter 3. Or unit 3, whatever they call it in math. This week, today, I'll put it up. But don't worry, you guys can take a couple days to do this. I'll probably make it due, let's say like Thursday or Friday, and that way I can get it marked for you. And then on Sunday, we'll have your last test number 2, only on unit 3. And we can do review for that on Thursday. We might start a little bit of chapter 4 this week because I think I'm going to almost finish unit 3 today. So we're doing so good for time. We have like almost 10 classes left, maybe 9 classes. And chapter 4 is very, very short. So yeah, this works out. Cool. All right. Any questions on that before I do number 10? All right. I'm going to clear my writing in a minute. So, just hold on there. I just ran over my toe with my chair. That wasn't very fun. I'll make a post of this on the D2L. So everything I just wrote down, I'll make a post after class today for you. Okay, so I don't know if your name is Lolo or Lola because in I get on the attendance it says something Lola.
Yes.
Yeah, okay, good. Okay. Because I think on my attendance sheet, there's like a typo or something. But anyways, no, this is good. So you asked about number 10. A 30% acid solution and water. Okay, so this is an important one because we're just adding water, are to be used to obtain 200 milliliters of a 2% acid solution. How much of each are needed? Now, the interesting thing about water, I'm just going to go up for 1 second. When we add water, the percentage here, the amount of water we're adding, or the concentration of water is 0. Okay, so this actually becomes a pretty easy little question here when I do this. The concentration of water, you can't really calculate. I think there's a note up above it. It talks about that. But when you're dealing with water, the concentration of that is nothing or 0. Concentration is moles of solute divided by, well, sorry, I'm talking about chemistry. Concentration is like the amount of solute divided by solvent. But in this case, adding water, we're not actually adding any concentration. So that number would be 0. So let's set this one up. A 30% acid solution and water. So it's going to be acid, my mixture of acid, plus my water are going to make 200 milliliters of 2% solution. Okay, well, let's see. The amount of acid, I'm going to call X, and the amount of water will be 200 minus X. Okay, so let's see. 30% acid, so 0.30 times X plus my water. Now you don't actually need to write this down, but I will put it there, times 0. Anything times 0 is just 0. Equals 200 milliliters times 0.02. Okay, so this becomes 0.30 X equals 200 times 0.2. I should be able to do that in my head, but I'm just going to double check that it's 4. So X will be 4 over 0.30, which is 13. Oh, I wish this was a better looking number, but anyways, 13.3. Let's keep it like that. 13.3 milliliters, about 13.3. Now, that's how much acid I need. The water is going to be 200 minus that number. Okay, so that should be what? 187.7 or something like that. I'll just do it on my calculator to make sense, make sure. 186.7, sorry. There we go. So, and again, think of your numbers. Think to see if they make sense. And I'm not asking you to like, know this perfectly, but if I was going to take 30% acid and reduce it to 2% acid, I would only need a little bit, right? So I'm going to need about 13, 14 milliliters of the acid mixed with the remaining amount of water, 186.7 mils of water. And that gives me my answer. And the answer makes sense. If the answer was, if you calculated this and it said like 160 milliliters of acid, that doesn't make much sense because we're trying to go from 30% all the way down to 2%. Okay, let's skip ahead a little bit. And I'm not trying to like skip anything. It's just we don't need to do every example. Let's look at some of the ones down here. Let me check the chat first as well. I have a question, a private message I don't understand. You're saying the word pulse, P-U-L-S-E. I don't know what you mean by that. Or do you mean plus? The question, I don't really understand the question too much. Sorry, I really don't, I don't understand the question. But I don't know. Well, let's do some more examples anyways, and maybe we can figure it out in the other examples. So let's skip ahead a little bit. And again, you guys should definitely practice these. They're all the same, basically. Oh, it gets a little different around 15. So let's look at 15 and 16. How many milliliters of a 0.05% solution, so this is weight over volume, how many milliliters of sodium chloride can be made from 120 milliliters of a 0.5% solution? So I'm going to give you guys a couple minutes to, see if you can try this one. This one is a little bit different. And if you finish 15, you could also try 16. Let me zoom out here. Oops, sorry, not that. Hold on, view. Oh, hold on. Just give me, I keep clicking the wrong button. View. Yeah, okay. I'll zoom out a little bit. Oh, I don't know if that's going to work. It's too small. Well, try 15, and then I'll give you guys some time to try 16. So I'll be back in a couple minutes. Give number 15 a try. We'll look at your answers. Okay, we'll look at the answer to this in a minute. This one's actually easier than it looks. Example number 15. So, okay, let's look at the answer to this. Let's see what we get. Again, this one's actually easier than it looks. Sorry, let me check the chat. Because in the chat, somebody, there we go. Asma is correct in the chat. You said 12 milliliters first, but the answer is 1200. This one's deceptively easy. Okay, the difference with this one is it's kind of reversed, meaning I'm going to take a solution. So I'm going to take, I'll kind of write out my plan for you. I'm going to take 0.5% and 120 milliliters. Okay. I'm going to add water to that. Now I know it doesn't say that I'm adding water, but what I'm trying to do is dilute this, right? I'm going from 0.5% to 0.05%. So I am going to add some water here. And the amount of water actually doesn't matter. I'll talk about that in a second. And what I'm going to try to do is figure out how much of this solution can I make. Okay, so instead of calculating like how much of ingredient A I need or how much water I need, I'm going to try and see how much of X can I make by diluting it. Now, when we're adding water, we're multiplying by 0. So this becomes a very easy equation. The only problem I had was I kept messing up how many zeros to write. So this would be 0.125. Okay, so like two zeros times 120 milliliters equals 0.0005 times X. Okay, make sure I got my zeros right. And that's it. And we don't need to worry about the water because the concentration of that is times 0. So X is going to be 0.005 times 120 over 0.0005, and you would get 1200 when you did this. Now, there's something missing from this question. I think this book could use a little bit of work. It's actually telling you that these are weight over volumes. That's fine. We don't need to worry about grams or anything because the units, are canceling. But our answer here would be in milliliters because this was in milliliters. So we could make, and guys, this one's deceptively easy. We're taking 0.5% and we're trying to change it to 0.05%. That means you can dilute it by a factor of 10. So we can make, instead of 120, we can make 1,200 milliliters. We're dilute, like, again, it's easier if you think of this like chemistry. We're diluting it by a factor of 10. So the volume gets multiplied by a factor of 10. But you can just do the math if you want there. All right, Calcium got the same answer. All right, what about, let's see, what's 16 saying? How many milliliters of a 25% weight over volume solution of a drug are needed to prepare 50 milliliters of a solution containing 20 milligrams per milliliter? Okay. So, well, as usual, before I do the answer, I'll give you guys a couple minutes to try this one, try number 16, and I'll be back with the answer in a minute. And then I think after 16, I'll probably move on to the last topic, because again, these are just all the same practice problems over and over. Maybe I'll do 22 as well. But yeah, take a few minutes, try 16, then we'll have a look at the answer. there is a little tricky step here. I just did the answer on a piece of paper, but I'll see if anybody can get it. There is one tricky step. I'll give you a hint. This concentration is in percentage. This is in milligrams per milliliter. So you might want to get them to be the same. And if you don't know what to do, I can show you. But there is a little trick to this one, and I'll be back in, let's say, 2 minutes, and we'll look at the answer. So anybody get the answer for this one, number 16? Okay, so asthma, sorry, I don't think I was talking and I was muted. Asthma got 4 milliliters, calcium getting very big numbers. So asthma, so 4 milliliters is the answer. What did you do, or your steps? Was it challenging to do those steps? Okay, I think I got an easy way to show you. I'll give everybody another minute or two to try this one, but see, because Kalsum said he's getting something a little big. The answer is 4 milliliters. So I'll give you guys a little bit more time to try this one. This one, again, it's kind of like it's not, it's easy, but sometimes it's hard to see the steps. So I'll give you a couple more minutes and then we'll look at the answer. All right, let's look at the answers to this one. I didn't get anybody else saying 4, but this one's a little easy. The trick to this one, like I mentioned at the beginning, is the problem here is that the concentrations are not the same. You can't compare 25% weight over volume to 20 milligrams per milliliter. So the first step here is to actually first find the concentration in, you could go in milligrams per milliliter for the first one, or weight and volume in the second one. So what I'm going to do, first step, is I'm going to change this to the concentration of weight over volume. Okay, so concentration of weight over volume, if you remember this, actually, I typically would just go weight / volume, is always the grams of the active ingredient over the volume in milliliters. So the problem with 20 milligrams per milliliter is step number 1, and this is probably why calcium, you were getting really big numbers, is I want to change this into grams. So 20 milligrams to grams would be divide by 1,000, so 0.02 grams per milliliter. And now I'm ready to go. So all I need to do is do my equation like I did before. I'm taking a 0.25% solution, or sorry, 25%, which is 0.25% solution. And I'm trying to find out how much I'm going to need to create 50 milliliters of a 0.02 solution. Oops, sorry, I just want to get rid of these 3 lines. Hold on, sorry. I just want to get rid of those lines. So 50 milliliters of 0.02. This is my percentage in grams per milliliters, which is what this one is. Right, so the key to this one, like in physics or math or chemistry, you need to keep the units the same. And now I just solve for x. X would be 50 times 0.02 divided by 0.25, and that would be 4. Whew. Easy, but not easy, right? You know, each of these questions takes a little bit of time to do. And let me check that on the calculator. I just did that in my head. So 50 times 0.02, yeah, divided by 0.25, perfect. All right. Yeah, so calcium, the reason you got a big number like 4,000 is because you needed to divide the concentration of milligrams per milliliter by 1,000. I think that was the only thing that was probably confusing a lot of you. You guys were getting probably 4,000 instead of 4. And the challenge for this one is the concentrations were not in the same units. You know, again, it's like in physics. If you're solving for grams, everything needs to be in grams. Here, I needed to make sure that these were in the same unit. All right, let's try an easier one. Let's scroll down a little bit. Let's look at an easier one here. Let's see. Okay, let's do 20 and 21, and then we'll check the time for today. Okay, number 20. How many milliliters of water should be added to a 50 milliliter solution of 23.4 sodium chloride to prepare a 9% solution? Okay, so for this one, first we're going to figure out, well, the easiest thing for this one is to solve it like we did before. So here, let me set it up for you. I have 50 milliliters of a 23% solution. Now, notice, guys, the units here are the same, so I don't need to do anything fancy. So I'm going to start with 50 milliliters of a 23, oops, let me change that to a decimal, so 0.234 times 50. I'm going to add water to that. And I did that in the above question too. Just remember, when you add water, you're actually adding nothing. So the reason I'm writing water here is because the question is going to ask me about this. But remember, when you add water, that calculation or concentration is a 0. And I'm going to try to make a 0.9% solution. Now the question is, first, how much of this solution will I actually have? So if I have 50 mils of 0.234% solution, how much of that solution could I make for it to be 0.9%? Oh, and sorry guys, obviously 0.9 has to be changed to a decimal, so 0.009. Now this isn't the answer, but this is the setup for that. So X will be 0.234 times 50 over 0.009. This is going to be the amount of the final solution. So keep in mind, it's not the answer, it's the final solution. I deleted, or I cleared my calculator. Sorry, hold on. Okay, so I end up getting 1,300 milliliters of solution. Now, that's of my total solution. Let me just change my color here. So what this means is, when I want to find the water added, well, I have 1,300 milliliters total. 50 milliliters of that is my initial solution. So I'm going to need to add 1,250 milliliters of water. All right, let me just check the chat here. Oh, and I'm sorry, Asma earlier said I did it a little different, but I got the same answer. So yeah, that's fine. Okay, let's finish this off. Let's do one more, and we can do method number 2. Actually, guys, method number 2 isn't a new topic. It's just another method to solve these. So really, we've already finished this chapter. I'm just going to show you another method to solve these, kind of an old school method, but we can do that tomorrow. So let's do one more of these. What one do we want to do? Oops, sorry, I went down too low. Let's try number 21. Now I'll set it up and then I'll get you guys to take a minute to try it, and then halas, that'll be it. So example number 21 says, what is the percentage strength of ethanol in a solution resulting from combining? Oh, this is an easy one. Okay, we'll do this one. Try this one. We're trying to find the percentage strength of ethanol in a solution resulting from combining 5 milliliters of 2% and 10 milliliters of 4%. So you guys know the method for this is, you take your mixtures, add them together to equal your total. But there is one extra step here. We're trying to find, in this one, the concentration, but how much of it do we have? Well, there is a very easy way to find that, but I'm going to leave it for 2 minutes. This is an easy one. I'll give you 2 minutes and then we'll look at the answer. All right, one more minute. This one is like kind of more of a classic one. There's only one little extra step for this one. So just take one more minute and we'll look at the answer. All right, let's have a look. Now let me clear my writing. I'll see if anybody got the answer as well. This one again is, well, I could say this about all of them. Once you see the answer, it kind of makes sense. It's just setting it up as the challenge. So what we're doing, let me just see if there's an answer. Okay, I'm getting 50% and 50% and another 50%. Okay, let's see. I don't know. I didn't do it. Okay, so what is the percent strength of ethanol? Oh, I don't think it can be 50% because we're mixing together 2% and 4%. But anyways, what is the percentage strength in the solution combining 5 milliliters? Okay, I don't need to write milliliters of 2%, so 0.02. Plus, I'm going to add 10 milliliters. Oops, I keep wanting to put the units in like I'm in chemistry, times 0.04. And now what we're going to do is we're going to make a solution, but remember, we're combining 5 and 10. So we're going to make 15 milliliters of this solution. Okay, so we're going to see what happens when we mix these together. So 5 times 0.02. Of course, I did it wrong in my calculator. Gives me, well, okay, I'll just add this up together. Just let me do that right away. Plus 10 times 0.04. So I get 0.5 equals x times 15. So x would be 0.5 divided by 15. So what I end up getting is 0.033 repeated. Now, this is a decimal, so the answer would be about 3.3 repeated percent. Again, I think what a lot of you guys did is you forgot to multiply that x by the total volume, 15. Let me just check the chat there. Yeah. So I think Kalsum said you missed the 15. That's why a lot of people were just getting 50%. Remember, these boxes, 1, 2, and 3 must always be the same thing. It must always be the concentration of the chemical times the amount. Okay, so this was, 5 milliliters times 2%, 10 milliliters times 4%. Well, this was my percentage as X times by the 15 milliliters total. So it'll take a bit of practice for this, guys, but you can have all week to practice this because the assignment, I'm going to get the assignment done this afternoon and share it with you. That won't be due until, let's make it due like Friday so you can get your marks back. All right, guys, that's it for today. Tomorrow, I'm not going to teach you anything new, not really. I'm going to show you another method to doing this. So if you guys aren't fans of this method, there is another kind of old school method called alligation. I think I'm saying that right. All right. Okay. So 1 second there. Well, that's it for me. You guys can leave. Just hold on. I got to check something for Abdullah and Loa, but I'm done, guys. So if you want to leave, you can. For Abdullah and Loa, just give me 1 second. Thanks, Reem, Kalsum, Zarina. Thank you, everybody. Have a great day. Thanks, everybody. Bye. See you later. Abdullah and Lolwa, I'm free now if you guys have any questions. Bye, Asma. See you later. Bye, Aisha, Anud, everybody. But for Abdullah and Lolwa, I'm free now for a little bit if you have any questions.
Yes, Mister. I have a question about the office hours.
Yeah.
So, on Thursday we joined, but we didn't find you.
Oh, okay.
Yeah.
And
So what?
what's your question?
We need to study. Like we need to review.
Okay, I'm free now if you have any questions.